Hi learners, hopefully you're doing well, and welcome to our channel. In today's video, we are going to do a past paper. Question 1. Consider the following characteristics of set of data, which is median 14, upper quartile is 20, lower quartile is 11, maximum is 30. So what we can do here, we can compute the data set. Median is Q2, then upper quartile is Q3, lower quartile is Q1, maximum, and then from the range we can find range is equals to max minus minimum. Okay, let's try to answer the question. Number 1, they said calculate the interquartile range. Interquartile range is equals to Q3 minus Q1. What is Q3 here? Q3 is 20 minus 11 is equals to 9. So draw the box and whisker. We don't have the minimum value. We can calculate the minimum value by using the formula of a range. A range is equals to max minus minimum. So range is 20 is equals to, what's the maximum value? Let's look at the maximum value. Maximum value is 30. 30 minus minimum. So when you transpose this m to this side, it's going to be positive m, and then 30, 20 this side, it's 20, m equals to 10. Okay, so let's dive into it. We have to sketch the 5-number summary. It's a minimum, Q1, Q2, Q3, and a max. Let's represent our data set. Minimum is going to be 10. Q1 is going to be 11. Then weekly, it's median. Let's check the median. Median is going to be 14. This is 14, and then Q3 is 20, and the maximum value is 30. Right? And then the next question will say comment on the skewness. Comment on the skewness, since you see that this space, your number line properly here. This space is bigger than this one, so it's going to be skewed to the right, or positively skewed to the right. Okay, we are doing the next question. Allow me to do question 3, then we are going to come back to question 2. Question 3. What does question 3 states? Question 3 says, write down the gradient of PQ. Write down the gradient of PQ. Let's see the values. The diagram shows P and Q. Point A is the midpoint. The line AB perpendicular and intersects the x-axis. So the coordinates of PQ, the gradient of PQ, let's just dive into it. Gradient of PQ is equals to y2 minus y1 over x2 minus x1. So PQ, this is the line PQ. So we're just going to say 0 minus 2 all over 4 minus 0. The value of the gradient is minus 1 over 2. Right? And then we dive into the next question. Calculate the coordinates of A. What is A? A is the midpoint of PQ. You see, A is the midpoint of PQ. So we write A like this. The formula for midpoint is x1 plus x2 all over 2, and the y value y1 plus y2 all over 2, right? And then it is about time we put the values. When we put the values, what is that thing going to result into? A is 0 plus 4 all over 2, and then by using these coordinates, 2 plus 0 all over 2. So when you punch this, you find that A is 2 is to 1. Right? Okay, next question. What does it state? It says what? Determine the equation of the line AB in the form y equals to mx plus c. Let's look at the line AB. The line AB is perpendicular to this one. This line is perpendicular to this line. So when these two lines are perpendicular, we are going to use these properties. M1 multiplied by M2 must be equals to negative 1. So in our case, looking for MAB multiplied by this M, and the value of that M calculated to be 1 or minus 1 over 2 equals to minus 1, and multiply by minus 2 both sides. So MAB is equals to 2. So hopefully you are following, but we're not looking for M. We're looking for the equation of a straight line. There's a formula which states that when you're looking for an equation of a straight line, y is equals to mx plus c. So when you're doing that, you know the m now, you substitute this point. What's the coordinate of A? 2 and 1. Use a different color. Alright, when you substitute that point, wherever there's y, you put the y value equals to m, which is the gradient, and this is 2 plus c. You manipulate and maneuver. You solve for c to be minus 3, and the formula of that equation is y equals to mx 2x plus c, which is minus 3. So we are done with that question. Let's see the next question. Calculate the length of PQ. If it is given that P is 0 and minus 3, let's see if I have space here. Okay, PQ, you have coordinates here. I think the top space will be very handy. You have coordinates here. You are looking for the length of PQ. You're given the coordinates of P and you know the coordinates of Q. So let me put the coordinates of P so that you calculate nicely viewing the coordinates, because sometimes what can confuse you is finding the coordinates 0 and minus 3. So PQ is equals to square root of the formula. You know the formula for distance: 4 minus 0 all squared plus 0 minus 3, which is plus 3 all squared. So 4 squared, it is 16. Okay, you can just punch this straight. 16 plus 3 squared is 9. 16 plus 9 is 25. Square root of 25 is 5 units. Right? Okay. The next question will say what? If PQR is a rhombus with R in the first quadrant, calculate the coordinates of R. So let's look for the coordinates of R. Means this shape is like this. You extend this one. You extend it like this. That makes this thing a rhombus. And then you notice that if this thing has now become a rhombus, A is now a midpoint, right? A is now a midpoint. You can find this X and Y using midpoint the formula. I almost said midpoint theorem. So you will use this point as well. So this coordinate we did calculate, and it was given that it's 2 is to 1. Okay, 2 and 1. So let's calculate the x of R, which is x plus 2 all over 2 is equals to 0. When this thing crosses the side, it's going to be x is equals to 0 minus 2. X is equals to minus 2. It was something, right? Oh, sorry. The value, the x value of the midpoint is not 0. It is 2. This is the one which is 0. So, right? And when you cross multiply, what do you get? Keep on making mistakes. Okay. Let's continue. The next question, what are they looking for? Oh no, we didn't calculate y yet. The same approach. Y plus minus 3 over 2 is equals to 1. When solving the y, multiply both sides by 2, y equals to minus 3. Okay, we need to step for learners. Y minus 3 equals to 2. So y equals to 5. After getting that, so you have a coordinate of r. Coordinates of r, x is calculated as 4, and then y is 5. Following, are you understanding? Are you winning? Calculate the length of PQ if it's given that we did calculate the size. Calculate the size of ABQ by looking for this size. Let me show you what I'm looking for from the diagram. We're looking for this size. It's going to be tedious, this one. It's going to be crazy. We're looking for this angle, right? When your algebra is correct, you will get these angles proper. Okay, let's dive into it. The secret here is to use this formula 10. Let's make this one to be theta. Let's make this one to be beta. And then you see that beta is vertically opposite. So 10 theta equals to m. And then 10 theta equals to m. What's the m for this line? M for this line. What is the m? We did calculate the m of this line, which is minus 2. So, was it minus 2? No, it was a positive 2. It's 2. And then when you punch here, 10 inverse, it's 63.43. Okay, after getting that, we can get beta, or we can get this g. This g is 180 minus that, but it might not be necessary. Let's get this p. How can we get this p? We don't have an angle, a gradient for pq. M pq. Let's calculate m for pq. M pq. M pq is equals to, what is the m here? It's going to be minus 3 minus, what's the value? Minus 4 all over. And then what's the value there? In B, 0 minus 4. So the gradients for PQ is what? Is 3 over 4. We said this is beta, right? So 10 beta equals to 3 over 4. So what is beta now? Beta is 36.87. Now you have this one. You can find Q1 is this one equals to this one. Y vertically opposite. So Q1 here. Okay. Then let's do, we're not done yet. It might be tedious, but we can use this tool, exterior angle of a triangle. This one, have you seen something like this? Since you know that this is beta, sorry, this is theta, this is, what is this one? This is Q1. I can easily say this one plus this one equals to theta. But because we're looking for beta, you can use the exterior angles of a triangle like this, or you can start by calculating this and do the sum of angles in a triangle. Let me do it. A, B, Q, which is this line, plus what is this? Plus ABQ plus what? Plus this one plus Q1 is equals to theta. You write the reasons, please. Exterior angles of a triangle. You see? Okay, you write it properly. Then let's substitute the values. When we substitute the values, we find that what are the values when we substitute here? A, B, Q plus, what is the angle of Q1? 36.87 is equals to what? Exterior angle 63.43. 63.43. When you manipulate, this thing comes to the other side. Therefore, angle A, B, Q is equals to, what is it when you punch in your calculator? 26.56. Okay, it's perfect. Let's proceed. The next question, what are they looking for? Let's check the question. Determine the equation of the circle passing through A, P, and B. So the circle passing here, let's try to construct the circle. The circle is passing here. Oops. The circle is passing here. It is passing here. It's going to be an oval, this one of mine. Right? So when a circle is passing here and this is 90, it means that this line is a diameter. So we can find the center of this circle. I don't know what can we use, but we can use a midpoint and calculate the center here. Do you agree? Midpoint formula and calculate the center. So why did we say this one is a diameter? You give a reason A equals to 90, angles in a semicircle, right? Okay. Then let's do it. The midpoint here is what? 2 minus plus minus 1 plus minus 3. It's minus 1 divided by 2. So it's 0 minus 1 over 2. So now you have a center. You have 1 point, at least 1 point. You can substitute that 1 point and solve for r squared. So which point can we use to substitute? Which one? Let's use the same one. Let's use B, the 2 and 1. A, let's use A. A is the common example. Let's use A. When we're using A, we are substituting in this formula. So equals to r squared. Are you following? Are you following? Which point can we substitute? Which point is substituted to? This one is substituted 2 and 1. Wherever there's x, you put 2. This one is for the center, minus a 0 squared plus y is 1 minus b is 0 all squared equals to r squared. You punch this whole thing in your calculator. What do you get? You get r squared to be equals to 25 over 4. So therefore the equation of the circle is x minus the center, which is minus 0, plus y minus b. What is b? The center of the circle. The b was minus half, so plus half all squared is equals to this one. Hopefully you understood. Let's do the next question. So the line is perpendicular to PQ, intersect at xg, y equals to, let me read properly, guys. Oh, I went up again. Sorry about that. The equation of the tangent at point P. You see, point P is a diameter. here is it when P is a diameter. So when point P is a diameter and it's passing you and we have a tangent, this simply means that the equation of this thing passing through P is y equals to the diameter equals to 2. Oh, that was generous. Okay, we proceed. We are going to do question. Oh, we're done with this thing. Oh, the equation of the tangent to the circle is y equals to 2. That's it. Let's do the next one. Have you heard of this guy called completing the square? Completing the square is going to be very handy when you're working with circles. Try to remember the completing of the square. So for instance, they are looking for the coordinates of B. We are going to find that by completing a square. Without any further waste of time, let's dive into it by doing question 4.1. We're given this equation, right? Let me rearrange x squared plus 8x plus y squared plus 4y minus 28 equals to 0. So looking for this field of p and x. So we can just say x squared plus half plus 8x plus half of 8. What is half of 8? Is 4, and 4 squared is 16. And then plus y squared, half of 2 is 2 plus 4y as 2 squared, which is 4. And then is equals to 28. To make it fun, let me add the 16 and a 4 plus 16 plus 4. Okay, then we factorize this one and we factorize this one as well. When we factorize this one, we have 2 brackets, or use the long method. The 2 brackets equals to r squared. Okay, so coordinates of the first of this thing, when we substitute this guy, it's going to be x plus 4, and then when we solve the other one as well, it's going to be y plus 2 all squared. So they don't have, then the values here, it's x equals to minus 4, y equals to minus 2. And this might look normal to you, but if you haven't practiced completing the square, to recap the completing the square, it's a half of the coefficient of x, and then you squared that. You see, it's a 16, then you add it. Half of 4 is 2. You squared that, you got a 4. Since you added 16 this side and a 4, you add the 16 and the 4 even the other side. Okay, all right, then let's proceed. So we have r squared, but what are the radius of the circle? The radius of the circle, we have r squared, 8 plus 16 plus 4 plus 4. R squared is 58 roots. 58 roots. R squared is 58 root. Oh, okay. Now let's proceed. The center of a circle, of another circle with the center A is drawn. The equation of the circle is this one. Okay. Show by calculation that these two circles intersect each other. Okay, we have to calculate the distance between the centers. Okay, let me try to show by calculations. The distance between the centers is what? What's the distance between the centers? Let me write the coordinates of the centers first. A minus 4, okay, it's plus 4 and 6. How about B? How about B? Where is B? Okay, it is 4 and 6. 4 and 6. Okay, I already wrote that one. And the other one is what? The original one. It is minus 4 and minus 2. Minus 4 and minus 2. Okay. The distance, using the distance formula. What is it, guys? What's the distance? You calculate this distance, it's going to be AB is equals to square root of minus 2 minus 6 all squared plus 32 minus y1. Right? That's the distance in between. And then you also calculate the distance between the radius. The distance between the radius. So R's, you'll get the total here. You'll get the total. Oh no, why am I using y2 and all those things here? Because there are numbers. Someone is messing with these things. Y2 is like, oh no, what have I done? AB is square root of minus 2 minus 6 squared plus minus 2 is minus 4 squared minus 2 minus 6 all squared. And R is what? 6 squared is 36 plus 64, which is 10, right? And then the other one, the sum of the radius r1 plus r2 is equals to what? We already saw the other one. It was like root 128. But the other one is what? Root 26, which is, when you add them, what do you get? When you add these radiuses, r1 plus r2 is equals to what? Equals to 12 point 12 point what? 12.71. So the distance between the two radius and the distance between the two centers is greater. So meaning the centers overlaps, and yeah, you will be able to get it. Okay, try this one. Try to attempt it. Let me drink water as you are attempting this one. Attempt it right here. Do it and see what you get. Are you almost done? We'll pause it and continue. Okay, I am continuing. So most of the calculus contains Euclidean and trigonometry and analytical. When your Euclidean is good and your analytical is good, so trigonometry is fun. At the end of the video, I'll try to give you, or somewhat during the video, I'll try to give you hints on how to pass paper 2. Okay, let's do this one. Calculate the value of the expression if theta is equal to 20. This one is easy. Everywhere where you see theta, you're going to put 20. And when you do that, you find this value 0.76604. When you round it off, this is going to be 0.77. Okay, that was easy. Then here it says prove without the use of calculator that this expression, it is indeed equals to cos 2 theta. Let me see if I have room. Let me see. Can I use the space? Maybe the space can work. You are given 1 minus 10 squared theta. You mentioned that left hand side, and then let me see, what do we have underneath? It's plus 1 plus 10 squared theta. 1 plus 10 squared theta. What can we do here? What can we do here? How can we do this one? We can change this to be sine over cos. 1 minus sine squared theta over cos squared theta all over 1 plus sine squared theta all over cos squared theta. Okay, this looks tedious, but it's getting there now. It's getting there now. So when you multiply this one, this is over 1. When you can try to make this one a single fraction, it's going to be something like this. Let me see if I still have space here. It's going to be something like this. We are proceeding up there. I'm just thinking it's going to be over cos squared theta, right? This multiplied by, and then you cross multiply like this, right? And then you'll have cos squared theta, and then minus sine squared theta. Okay, and we do the same for the denominator. When you do the same for the denominator, it's going to be all over cos squared x cos squared theta. So this one times this one is cos squared theta plus sine squared theta. I had a beautiful time. Okay, then we try to simplify. When there's a divide, when we change this divide, when we change this divide to be multiplication, the next step is going to be cos squared theta over sine squared theta plus cos squared theta, and then plus sine squared theta, cos squared theta plus sine squared theta, and this one is equals to 1. Let's do this. This cancel. this one is equals to 1, and this one is a double angle, which is basically cos 2 theta. So it is indeed proven as far as I can see. Hence, or otherwise, find the general solution without the use of calculator. Already we have this one to be equals to half, and we know that this one is equals to cos 2 theta, right? So let's acknowledge this guy. Let's acknowledge him. This one is say is sine 2 theta is equals to 1 over 2, and then a ref angle is equals to 60. All right, how did we find the 60? We used our triangle, which is very useful in trigonometry. 60, 30, and 1, 2, root 3 and 2. So yeah, after getting the reference angle, you can easily say 2 theta is equals to 60 plus k 360 when k is an element of integers. So we proceed. It's not only a first quadrant. Let's divide everything by 2 here. Theta equals to 30 plus k 180. K is an element of integers. Okay. And then how about the third quadrant? Third quadrant is like fourth quadrant. Cos is positive also in the fourth quadrant. Right on top, hopefully you will see. Reference angle is 60. Fourth quadrant, you will have 2 theta equals to 60 minus 360 minus 60 is 300 plus k 360. Divide everything by 2, theta equals to 180 plus k 360. No, after dividing by 2, even the period is now affected. 180. When you divide 2 out. Are you sufficing, my people? So express the following in terms of k. When they did not give you a demarcation, you take this thing and put it in the first quadrant. Just put this thing in the first quadrant and you see magic. So cos 25 is equals to k over 1, and this is the 25. So yep. And then what's happening here? You can find the unknown side using the theorem of Pythagoras. This one is 1 minus k squared. How did we find it? We did it like this. R squared equals to x squared plus y squared. So R is 1 equals to k squared plus y squared, and you transpose 1 minus k squared, just put the square root. That's how we found it. Okay. Express the following in terms of k. You know that this one, you can reduce it. Let me just write the unknown angle. If this one is 25 here, it's going to be 65. Here is 90. You're going to reduce this thing to be 180 plus 45. 180 plus 45. Is it? No, it's not 180 plus 45. Because 180 plus 45, we are not getting 245. So it's going to be 180 plus 65. So 180 plus, where is it? In the third quadrant. So it's going to be minus sine 65. And then which is and what do you get? Sine theta. Sine theta. Why did I put theta here? Where did I get the theta? This is going to be minus sine 65. Sine 65 is k over 1. Because the minus was already there. Minus k over 1. Okay. Then the sine 25. Sine 25 is this one, opposite over hypotenuse. Sine 25 is like root 1 minus k squared over hypotenuse over 1. This is sine 25. Cos 50. Cos 50 is interesting. Cos 50 is a double angle, which can be expressed as cos 50 can be expressed as what? As 1 minus sine squared 25. Okay. 1 minus sine squared 25. Sine squared 25. 1 minus k squared. The squared takes out the root. And then when you simplify this thing, what are you going to get? What are you gonna get? Sines opposite over hypotenuse. Okay. Or you can expand this one. Oh, sorry, we made a mistake, guys. This one, which one are we doing? We're doing, okay, we did sine 25. Now we're doing cos 50. Cos 50 is the same as cos 2 times 25. And you expand this to double angles. Double angles. I don't know which one. You can use it like this. 2 cos squared 25 minus 1. So you're gonna get it. You get it, and then square 25 It's serious here. Let me write properly. I expanded the double angle minus 1. So square 25 is 2 cos adjacent of hypotenuse k squared minus 1. Okay. We're now in 5.3. 5.3.1. Consider square root of 3 cos b plus sin b. Rewrite root 3 cos b plus sin b in the form of p minus 1. Are you winning? Okay, are you winning? Try to do it. Okay, I have space here. Let's do it together. Root 3 cos b plus sin b. Okay, what can we do here? We can multiply by 2 over 2. Then when we multiply by 2 over 2, you can have root 3 all over 2 plus 2 over 2. See? Okay. Root 3 over 2. The birds are singing, guys. Plus 2 over 2 sine beta. We take out the common factor 2. When you take out the common factor 2, you are left with 2 into root 3 over 2 cos beta plus 1 over 2 sine beta. Okay. And then you know that this one from our favorite diagram, this one here is 30, this one here is 60, and here is 1, root 3, and 2. So how about the root 3 over 2? Root 3 over 2 is what? Is sine 60. 2 sine 60 cos beta. How about 1 over 2? What is 1 over 2? It's cos 60. And then multiply by sine b. So now this is a pure double compound angle, right? This is just clean pure compound angle. Oh, I forgot the brackets. Then this is going to be 2 when we solve this one. it's going to be sine 60 plus theta. Easy, right? Okay, determine the maximum value of this one. This one is easy. Maximum value. You look at what we just solved now. Okay. Max will be like, I'll tell you what we're looking for in our class. Okay. We're moving is the max value. Question 3. It's a graph of course that is shifted and all that. Okay, it's a graph of course, not shifted, just it's negative, reflected to the x-axis. We drink water. Attempt it. Pause the video because I'm not gonna wait now and try to do it. So on the same set of axes, in the answer, we'll draw the neat graph of f of x plus 30. So the learners loves this function. The learners loves using table method when they are drawing these things. But when you know the original graph of sine, the original graph of sine is here. The original, don't draw this one. What's happening with me? Original one is here. Shoop, shoop, shoop. Right? So when they say minus 30, everything is moved. So you take the original and move it every crucial point 30 units. You see? And that will cause a problem for everybody. So this is our drawing shoop. Cut here. It's not cutting at 1. It's not cutting at 90 exactly. But it can cut. It cuts where? And the period is this is something else. Okay. So this is not the thing is not here. Initially, this was cutting here, and then this was turning here. Now it's going to turn at 60. Right? Mirror draw properly. But you can use table method, guys. So it was supposed to cut where it's supposed to cut at 180. Now it's going to cut at 150. You see? Okay, it says here, show clearly all the intercept axis as well as the turning points. So these are turning points, intercept, you see? You can see them. then it says write down the period of G. 2x, G at 2x. You see G. You see G. G at 2x. So everywhere where there's 2, where there's this thing, you put a 2x. Where's the graph of G? G at 2x is this one. You just say G at 2x. Wherever there's x, you're gonna put a 2x minus cos 2x. That's it. Okay. They're looking for the period. This is the period. Period is the factor that affects. Period is the factor that affects the. This 2 is the factor that affects the period. Remember period. Let me just say P equals to 360 over K, and now K is 2. What is the thing? 1/8. Then the next one. Summand the values of x and elements of minus 90 to what? With the graph are both increasing. So this one here is increasing, and then this one is decreasing here. Okay, so that you don't become glued to one paper for so long, let me publish this part 1 and be ready for part 2. Thanks for watching. I will continue with the video in our next episode. Thank you.